Next question, question number 104. An electron of mass m with an initial velocity v equal to v naught I cap, v naught greater than 0, enters an electric field E, vector E is equal to E naught constant greater than 0 at t equal to 0 if lambda naught is the de Broglie wavelength initially, then its de Broglie wavelength at time t is. The four options which are given there. Option 1 lambda naught into t, second one is lambda naught, third one lambda naught into 1 plus E naught by mv naught into t, like this. Okay, it's just a correction. Lambda naught by 1 plus E naught by mv naught into t. Direct sum, simple, straight away apply the formula. Only thing you should know the formula. Okay, de Broglie wavelength formula, lambda equal to h by mv. So here the electron's velocity is along x-axis, but the electric field is applied along minus x-axis. Note that a negative charge will always accelerate along opposite to the direction of the electric field. Positive charge means it will accelerate along the direction of the electric field. Negative charge will accelerate opposite to the direction of the electric field because it's negative charge. These are all basics. So this will accelerate, and formula for wavelength lambda is h by m v t, velocity after time t, h by m, v is equal to u plus at, initial velocity is v naught, acceleration is e by m into t. V is equal to u plus, acceleration is e by m into t. You don't have to put minus e because we took this direction and it will accelerate in this direction. It accelerates along the negative direction of the electric field. Okay, so the speed will only increase. Okay. Yeah. After this, h by m v naught, take that v naught outside, 1 plus E by m v naught t. Lambda, the h by m v naught, we can consider as lambda naught. So this is equal to, from this you are writing, you are getting, this is lambda naught. So the answer is lambda naught by 1 plus E by m v naught into t. Lambda naught by 1 plus E naught, sorry, I have to put E naught, E. So E here, E here. But that's constant, so E naught. Because electric field doesn't change, no, E is minus E naught only. He has given only E naught in the question. See, E is equal to minus E naught and constant. So instead of E, you can even put E naught. So write it as E naught. So lambda naught by 1 plus E naught by m v naught into t. So option 4 is correct. Next question. Question number 105. For a radioactive material, half-life is 10 minutes. If initially there are 600 number of nuclei, the time taken in minutes for the disintegration of 450 nuclei is, So 450 nuclei are expected to disintegrate. The options 30 minutes, 30, 15, 10 and 20 in minutes already given. Therefore the answer is 30, 15, 10, 20. We have to find out. Which one is the answer? We have to find out. A very simple question. Half-life definition, if you know, you can easily do this sum. Half-life 10 minutes. So totally 600. From 600 to 300, time taken will be 10 minutes. Then because you see 450 to disintegrate, so how much should remain? 600 minus 450. 150. 150 nuclei should remain. 450 to disintegrate. So 600 in one half-life period, half of it will go, 300 will remain. Then in this, one half will go in another 10 minutes. So the number will become 150. So therefore the total time taken is 20 minutes. The answer is option 4. Next question, question number 106. When the light of frequency 2 nu naught, where nu naught is the threshold frequency, is incident on a metal plate, the maximum velocity of electrons emitted is V1. When the frequency of the incident radiation is increased to 5 nu naught, the maximum velocity of electrons emitted is V2. The ratio of V1 to V2 is 4:1, 2:1, 1:4, 1:2. We have to find out which one would be the correct ratio. How do you do the sum? Use Einstein's photoelectric equation. It says the energy of the incident radiation. I use this symbol, is equal to work function, which is h nu naught, plus half m V max square. Here the symbols will be little different, but this equation we can use as the reference equation. Energy of the incident radiation initially 2 nu naught into h, or h into 2 nu naught. Work function is h nu naught plus half m V1 square. 2h nu naught, h nu naught, take it to one side, that will be h nu naught, half m V1 square, equation 1. Similarly for the second part, initial energy will be 5h nu naught minus h nu naught, so 4h nu naught. Instead of 2h nu naught, put 5h nu naught. But this will be same metal plate. So 4h nu naught, half m V2 square. Suppose to find V1 by V2. So divide. H nu naught will go 1 by 4 is equal to half m will go V1 square by V2 square. Therefore V1 by V2 will be 1 by 2 or 1:2. Answer 4 is correct. Next question, question number 107. In the circuit shown in the figure, the input voltage Vi is 20 volt, VBE is 0 volt and VCE is 0 volt. VBE, VCE 0 volt. The values of IB, IC and beta are given by. Supposed to find IB, IC and beta. Finding beta will be easy because it's current gain in the case of common emitter configuration, and this is common emitter configuration. Output current by input current, IC by IB. So once you find IC, once you find IB, you can find beta very easily. But how to find that IB and IC? Use Kirchhoff's voltage law to the output side of the circuit. Okay, so here this is 20, this is grounded, so voltage here will be 20. So 20 equal to IC into RC. RC is 4 kilo plus VCE. VCE is 0. Therefore, this is IC into 4 into 10 power 3, which gives you IC is equal to 20 by 4 into 10 power 3, which is 5 into 10 power minus 3. So you get IC as 5 milliampere. IC as 5 milliampere. So this option is ruled out, of course, because it's given 10 milliampere. These are all the options given. All IB values or IC values and beta values. But there are 3 such options having this IC as 5 milliampere. So we have to find next one as IB. So we see same way. IB means input voltage, which is given to be 20, equal to, again apply KVL, IB RB. IB into RB is 500 kilo ohm plus VBE, VBE 0. Therefore, IB is equal to 20 by 500 into 10 power 3. Okay? Into 10 to the power of minus 3. But 2 by 50 is 4 by 100. So 0.04 into 10 to the power of minus 3. Therefore, this is you write this as this 10 power minus 3, because everything is given in microampere. 10 power minus 3 is there, no? You write it as 10 power minus 6, 10 power plus 3. Actually 10 power minus 3, 10 power minus 6, 10 power plus 3, 10 power plus 3 you add here, you will get 40. 10 power minus 6. So 40 microampere IB. So IB 40 microampere. Of course, beta you can find from this. It's enough if you find only these two, because this 40 microampere and 5 milliampere, only this is there. This is 40 microampere and 10 milliampere is there, so exclude. But anyhow, if you want to cross check, beta equal to IC by IB. What is IC? 5 milli. What is IB? 40 micro. So 1 by 8 into 10 power 3. Okay. When you simplify, you are getting 125. So beta will be 125. Therefore, option 2 is correct.